So here I am going to start. Question number 1. It is saying that let fxy is equal to x cube minus 2y cube. The curve along which del square f is equal to 0 is. Okay, see here in this question they have given one function, it is x cube minus 2y cube, and they are saying that its Laplacian operator is equal to what? 0. So Laplacian operator, you can say that either just differentiate it partially differentiate it 2 times, or simply take first, if it is a suppose that if it is a scalar field, then first take its gradient and then take its divergence. So by solving that one, you will get what? First differentiated, you will get what? 3x square. After that again second part, you will get what? 6x. And if this is equal to 0, then x will be equal to what? 2y. Question number 2. A curve is given by RT is equal to t I cap plus t square j cap plus t cube k cap. The unit vector of the tangent of the curve at t is equal to 1 is. See the next question. In this question they have given one curve, equation of curve, and they are asking the unit vector along the tangent. What is its unit vector along the tangent? So simply for tangent, for the slope of a tangent, what do you have to do? Or simply to find vector along the tangent. So first differentiate this one, the given function, you will get what? I cap plus 2t j cap plus 3t square k cap. Then vector along t is equal to 1 is equal to what? I cap plus 2 j cap plus 3 k cap. Okay, next you have to find that unit vector. Unit vector is equal to what? That given vector divided by its magnitude. So its magnitude is what? X square plus y square plus z square whole root under. So just you will get this value as what? Its unit vector. Question number 3. There are 3 planets in a circular orbits around a star at distance a, 4a and 9a. At time t is equal to t naught, the star and the 3 planets are in a straight line. The period of revolution of the closest planet is t. How long after t naught will they again be in the straight line? Okay, see in this question 3 planets are given, and first one is at distance a, next 4a, and third one is at 9a. Clear? What they are saying that the time period for first one is t, and at t is equal to t naught they are in a straight line. Now they are asking what? After what time again they will be in straight line. Clear? Okay. Now see, we know this relation that t cube is proportional to r cube. Clear? So you can calculate t. You can say that t is proportional to what? R cube upon r3 upon 2. Clear? Next, from here you can calculate time period for b and c. For a it is given as t. For b, just take square root of 4a, it will become what? 2, and after that cube. So you will get what? 8 t naught. For c you will get what? 27 t. Now at t is equal to t naught, they are in a straight line. Clear? So again after what time they will be in a straight line? So simply you have to take that LCM, lowest common multiple of all the time period. So you will get what? 216 t on taking LCM. A current I is flowing through the sides of an equilateral triangle of side A. The magnitude of the magnetic field at the centroid of the triangle is. Okay, see in this question, current I is flowing across along a equilateral triangle, and they are asking what is the magnetic field at the centroid of this triangle. Clear? Okay, see here current I is flowing, and we know that B is equal to what? From that Biot-Savart law, B is equal to mu naught I upon 4 pi r into sine of alpha plus sine of beta. Clear? And here sine alpha is 60, sine beta is what? 60 degree. So just put the values. Distance of this centroid is what? That a, we know that r is equal to what? This distance r is equal to what? A upon 2 root 3. So just put all the values, value of r and sine alpha and sine beta, you will get what? And here this is triangle, so for one side you will get this value, for 3 side just multiply it with 3. So answer will be simply what? R is equal to 9 mu naught I upon 2 pi a. So it is first option. Okay, see question number 5. Two vehicles A and B are approaching an observer O at rest with equal speed as shown in figure. Both vehicles have identical siren blowing at a frequency Fs. The observer hears these sirens at frequency Fa and Fb respectively from the two vehicles. Which one of the following is correct? Okay, see in this question there are two vehicles A and B and they are approaching an observer O, clear, and both have identical that both frequency of both vehicles, siren of the both vehicles are same, clear. That is how much, that is given as what, Fs, clear, that is given as Fs, and Fa and Fb is frequency, with that frequency observer heard the siren of A and B, clear. Okay, one thing is clear, speed of these two vehicles are same, and we know that in Doppler's effect speed, with what speed they are approaching that observer, that matters, clear. So frequency of both, frequency heard by that observer of both vehicles, of both siren of the vehicles will remain what, same. Next thing, because both are approaching observer, so frequency will increase. So here you can see in first option Fa and Fb equal, but this is less than Fs, so first option is incorrect. Okay, in second Fa and is equal to Fb and it is greater than Fs, so you can say that okay, second option is correct option. Question number 6. The three infinite plane sheet carrying uniform charge density minus sigma, 2 sigma, 3 sigma are placed parallel to xz plane at y is equal to a, 3a, 4a respectively. The electric field at the point 0, 2a, 0, 2a, 0 is. Okay, see in this question there are three infinitely long plate and they are placed in xz plane, and the first one having charge density minus sigma and it is placed at x is equal to a. Second one having charge density 2 sigma is placed at x is equal to 3a. Third one at x is equal to 4a having charge density 4 sigma, and they are asking what is electric field at y is equal to 2a. Okay, we know that due to infinitely charged sheet, electric field is equal to what, sigma upon 2 epsilon naught. Electric field is equal to sigma upon 2 epsilon naught. So see, due to this minus sigma, that electric field will be in this direction, so I can say that it will equal to minus sigma upon 2 epsilon. Due to this one, it will be away from here, or you can simply say that okay, just outward. So here 2 sigma upon 2 epsilon naught, 2 sigma upon 2 epsilon naught, and because it is along minus y axis, so it will be what, minus 2 sigma upon 2 epsilon naught. Here also same thing, 3 sigma away from that one, so it is equal to what, minus 3 sigma 2 epsilon naught. So electric field will be what, total electric field summation of all these three, you will get what, minus 3 sigma upon epsilon naught. So correct option is B. Okay, see question number 10. Which one of the following graph shows the correct variation of V0 with Vi? Here Vd is the voltage drop across the diode and the op amp is assumed to be the ideal. Okay, see solution of question number 10. Here one op amp is given and input voltage is given here, and we have to draw the graph, or we have to find the graph between VO and Vi. Okay, so here you can say that okay, if it is Vi, here also same potential, that Vi, it will carry forward here VO. So you can say directly that its graph, input and output graph, VO and Vi graph is what? It is simply a straight line, a linear graph. Like how Vi is increasing, in the same manner VO will increase. As you are increasing Vi, VO will also increase. Clear? So this is the correct graph for this question number 10 between VO and Vi. Okay, now see question number 13. A rectangular loop of dimension L and W moves with a constant speed of V through a region containing a uniform magnetic field B directed into the paper and extending a distance of 4W. Which of the following figures correctly represent the variation of EMF with the position of the front end of the loop? Okay, see here in this question, there is magnetic field B in the region here given, and direction of that magnetic field is inward to the plane. Clear? There is a coil, and this is a rectangular coil, and it is approaching, it is going towards that magnetic field region, and you have to draw the graph of EMF with X. That with X, what is its EMF when that coil is at different position? Okay, we know one thing, that EMF is equal to what? V L V cross B. Actually, that formula of EMF we are getting from where? E is equal to minus d phi by dt, and phi you can calculate that. Clear? B dot dA, and using all those things you can directly say that EMF is equal to what? L V cross B. Okay, now see here, as it is approaching here in this direction, what will happen when it will enter? So in that case, EMF will induce here. Clear? How much? VLB. Across this width, due to velocity of this part, there will be no EMF, and because its thickness is negligible, so you can say that that EMF will be generated across its two end. Clear? Two end of that towards its thickness. Okay, so now here what you can say, that initially that EMF when it is entering, EMF will be negative. After some time, again its EMF will be what? Positive. Why? Because now it is going away from, moving away from this loop. Clear? Moving away from this region. And you can also calculate the direction using Lenge's law, that as it is going entering into this region, that magnetic field is increasing, so it will try to oppose that. Same thing here, just opposite of that. Clear? So correct graph is here, this one. Now question number 14. The equation of state for 1 mole of non-radial gas is given by PV is equal to A 1 plus B upon V, where the coefficient A and B are the temperature dependent. If the volume changes from V1 and V2 in an isothermal process, the work done by the gas is. Now see question number 14. There is a relation of a non-ideal gas is given, that is what? PV is equal to what? A 1 plus B upon V, and they are asking that if it is expanded isothermally, then what will be that work done? Clear? So work done, we know that what? W is equal to integration of P dV, and if it is expanded isothermally, then you can say that temperature is what? Constant. So you can say that P will be equal to what? A 1 plus V plus B upon V square. This is your what? P. Work done is equal to P dV. So just multiply this with P and integrate this with respect to dV. So what you will get? 1 upon V. Integration of 1 upon V is what? ln V. Put that limit. Next, integration of 1 upon V square. That how much you will get? That is minus 1 upon V. After putting limit, so you will get what? 1 upon V1 minus V2. So this is the correct answer for that work done in this question, question number 14. Question number 15. An ideal gas consists of 3-dimensional polyatomic molecules. The temperature is such that only one vibrational mode is excited. If R denotes the gas constant, then the specific heat at constant volume of 1 mole of the gas at this temperature is. Okay, say in this question, they are saying that there is a polyatomic gas in which one vibrational mode is excited. Clear? So now they are asking in this question, what is its specific heat capacity at constant volume? Clear? So we know that if there only one vibrational mode is excited, in that case what is in translational mode there will be 3 degrees of freedom, in rotational there is 2, and there is one extra what? Vibrational mode of one vibrational mode is excited. So total degree of freedom is how much? 3 plus 2 plus 1, that is 6. We know that CV is equal to what? f upon 2r, clear. So here degree of 6 by 2, r is what, your Cp, and Cp minus Cv is r. So by that only you can calculate Cv. Cv will be equal to what, 4r. So correct answer here is 4r. Now question number 20. Consider two waves, y1 is equal to a cos omega t minus kz and y2 is equal to a cos omega plus delta omega t minus k plus delta k z. The group velocity of the superposed wave will be. See here in question number 20, they are asking group velocity, that what is the group velocity of two given wave, clear. Okay, see in for group velocity what you have to find, what you have to do, that simply group velocity is what, the change in wave number by change in its angular velocity, clear. So group velocity is k2 minus k1 divided by y2 minus w2 minus w1. So that how much, sorry, w2 minus w1 by k2 minus k1. So what you will get group velocity as, this is delta w, on subtracting these two, delta w by delta k. Question number 21. Consider a convex lens of focal length f. A point object moves towards the lens along its axis between 2f and f. If the speed of the object is v0, then its image would move with speed v1. Which of the following is correct? Okay, see in question number 21, there is a convex lens and an object is moving between 2f and f. So we have to find the relation between velocity of image and its position. Like we have to simply find the relation between a velocity of image and velocity of object. Okay, so one thing is that we know that thing, that whenever object is at 2f, image is also as 2f. As it is moving towards f, that object is moving towards infinity. So what you can one general perception or one general thing which you can say that if object is moving f distance, then object will move when object is moving f distance, in that case image will move infinite distance. So you can say that velocity of object is less than velocity of image and image is moving away from the lens. Question number 24. Which one of the following curves correctly represent the solution for the equation df upon dx plus 2f is equal to 3, where f0 is equal to 0? Okay, see in this question number 24, they have given one equation, one differential equation, first order equation this is, and they are asking the relation between its solution f of x and x, graph between f of x and x. So this solution is, that given differential equation is not that much tough. You can simply move this 2f on the other side and after that integrate that one. After that you will get this, in last you will get this equation, f is equal to 3 upon 2 1 minus e raised to power minus 2x, and its graph will be like this. There may be one confusion that why not this graph. So thing is here that you can see here in this graph slope is always decreasing, and in this case slope is first increasing and then decreasing. When you will differentiate this one, you will get one function e raised to power minus 2x, and you know that this is a decreasing function, continuously decreasing function. So here you can say that continuously slope of this graph is decreasing. So that's why this is correct one, not the other one. See question number 25. The mean momentum p bar of a nucleon in a nucleus of mass number a and atomic number z depends on a and z as. Clear? Okay, see in this question they are asking about how that momentum, mean momentum depends on whether it depends on mass number or atomic number. Clear? So that mean momentum is directly proportional to its mass number, not directly proportional, it is mass number raised to power minus 1 by 3. Clear? So here in this case you can directly say the answer, that mean momentum, option C is the correct answer. Question number 26. The Boolean expression AB bar, A bar plus B, A plus B bar can be simplified to. Okay, see in 26th question a Boolean expression is given and you have to solve this Boolean expression. Okay, see here we can AB bar can be written as what? A bar plus B bar, Next, just solve these two. So first on solving this one, a bar a we know 0, b a, just write all these things, clear. After that solve these two. What you will get? A bar b bar, that will become same, because a bar is same a bar. So you will get in last this quantity, and a bar b bar can be written as what? A plus b whole bar. So actually this is what? This is a NOR gate. Question number 33. The projectiles of identical mass are projected from the ground with initial angle alpha with respect to earth's surface and same initial velocity in the same plane. They collide at the highest point of their trajectory and stick to each other. Which of the following statement are correct? Okay, see here two objects are projected at an angle alpha and they are colliding with each other at highest point. Okay, when they are colliding at highest point, then what you can say that at highest point its velocity will be what? U cos alpha. Here also its velocity is U cos alpha, clear. And okay, you can say this one is minus U cos alpha as it is going in opposite direction. So momentum before collision it is 0, and when they are sticking together, then after collision also what? Momentum will total momentum is what? 0, clear. So what you can say that initially before collision total momentum of the system will be what? 0. After collision, if they are sticking with each other, then its final velocity will become 0, because U cos alpha minus U cos alpha, mass is same, so net sum will be what? 0. So final velocity is also 0. So object will move in vertically downward direction. So these two options are correct, because at highest point when they are colliding, total momentum is what? 0 of these two systems, and after collision they are coming vertically in downward direction. They will not, after collision they will not follow that projectile motion. Question number 38. In presence of a magnetic field B j cap and an electric field minus E k cap, a particle moves undeflected. Which of the following statement are correct? Okay, in this question number 38, B is given, it is B j cap, it is in j cap. Electric field is given as what? Minus E k cap, and a charge is projected in this region with some velocity v, clear. They are saying that what is the nature of charge and its velocity when in this region the charge is going undeflected. Okay, so we can take two cases. When charge is positive, in that case if we want no zero deflection, then that B cross V should be in opposite direction of E. That Lorentz force should be equal to 0. So we know that if here it is minus k cap, we want what? Plus k cap. So that should be in I, because I cross j is what? K cap. So that velocity should be in I cap direction, and its magnitude should be what? E by B. So V will be equal to E by V I cap when Q is positive, and just opposite when Q is negative.